how is it that electricity can power the world? How can it light all the lights in my home? How can it power my toaster, my washing machine, and not only all those devices in my home, but in billions of homes across the planet? I think I can explain simply how. But first of all, you'll have to imagine a mosquito. Now, a mosquito is made of atoms like you and me, and probably from school, you remember that an atom has a positively charged nucleus, rather like a sun, around which electrons orbit, rather like planets. And the nucleus is positively charged, and the electrons are negatively charged. And if you also remember from school, unlike charges attract. So it's that attraction between the nucleus and the electrons that keeps the atom uh, in one piece. Now imagine I could magically remove all the electrons from that mosquito. Then I'd just be left with the positively charged nuclei. And if you remember again from school, like charges repel. So basically, all the atoms in this mosquito would fly apart. The mosquito would explode. So my question is, would the mosquito explode with A, the energy of a sparkler, B, the energy of a stick of dynamite, C, the energy of a hydrogen bomb, or D, the energy of a global mass extinction? Now, when I actually ask an audience this, when I'm giving talks, a lot of people think it's a trick question and they go for C, the energy of a hydrogen bomb. But actually, it's D. The mosquito would explode with the energy equivalent to the city-sized asteroid that slammed into the Earth 66 million years ago and wiped out the dinosaurs. It's all down to the existence of a phenomenally powerful electric force. Um, we probably think that the force of gravity is strong. I mean, I can just about leap a meter into the air before it pulls me back to the ground. But the force or the electric force is phenomenally more powerful. In fact, it's 10,000 billion, 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 billion times more powerful. So that's one followed by 40 zeros. And this is why electricity can power the world. Because in the example of mosquito, I removed some of the electric charge and created a charge imbalance, and that unleashed some of this phenomenal uh, power of this phenomenal force. And what we do in order to generate electricity is we create a charge imbalance. And we actually see that charge imbalance in nature when there is a charge imbalance created between the ground and a cloud during a storm. And we see the force unleashed as lightning. So that's really the secret, is that there's this unbelievably powerful force. As I say, one followed by 40 zeros is more powerful than the gravitational force that pins your feet to the ground. And this force, you might think to yourself, well, why don't we actually notice it in everyday life? If I walk past someone on the street, how come I don't notice that this phenomenally powerful force is operating in that person and it's operating inside me? Well, the answer to that is that this force is both repulsive and attractive. So it's repulsive between like charges and it's attractive between unlike charges. And it just turns out that in all normal matter, there's a perfect balance of positive and negative charge. So this repulsion and attraction is perfectly cancelled out so that we don't actually notice it in everyday life. Now, this phenomenal power of the electric force is one of the great mysteries of science. Um, how can we have one force that is one followed by 40 zeros stronger than another, like gravity? And the only explanation that has been that even is remotely plausible has come from string theory. Now, string theory is a bit on the, well, it's going a bit out of fashion at the moment. String theory envisions that the ultimate building blocks of matter are actually tiny little strings, like little violin strings, enormously smaller than atoms, and their vibrations are what we see as particles. So a low energy vibration. Uh, a low note of a violin is a massive particle or is a light particle, and then higher harmonics are heavier particles. One of the problems with string theory is that it only works in 10 space-time dimensions, and we know from our observation of the world that there are only three space dimensions and one time dimension. So it kind of really contradicts what we see in the real world. And the other problem with string theory is it hasn't come up with any predictions that could be verified by experiment. But in string theory, it turns out in this 10 dimensional space-time where the strings vibrate, there are things other, or there are things that can exist other than one-dimensional strings. There can be two-dimensional objects, three-dimensional objects, four-dimensional, and these are called branes. So in this picture, a string is a one-dimensional brane. So it could be that our universe is what we call a three brane. That's a three-dimensional island floating in this 10-dimensional space. And this gives us a possible explanation for why the electric force is so much stronger than gravity, or alternatively, why gravity is so much weaker than the electric force. Because in this picture, all the forces are pinned to that three brane, our universe, except for gravity. Gravity is the only force that extends throughout the 10 dimensions. And in extending beyond the brane into these dimensions, it is diluted. So that's a possible explanation of why there's this incredible disparity between the electric force and the gravitational force.